No, please put your audio. Good morning, students. Manoj, please mute your audio. Thank you. So, good morning, students. So last class,
Good morning, sir.
okay, last classes we discuss about the DC motor. That is second unit of electrical technology subject. So in DC motor, so we clearly know about the what is the principle of DC motor, then what is the back EMF, after then the torque equation, then characteristics of DC motors, and also the applications of DC motors. After then we discuss about the speed control of DC motors, what is the necessity of speed control and what are the different methods of speed control. Then 3-point starter, necessity of starter, and construction and operation of a 3-point starter, and various losses occurred in the DC motors, efficiency of a DC motor, condition for maximum efficiency of a DC motor. After then we discuss about the tests of a DC machines, direct test and indirect test. Under that we have to discuss about the direct test is nothing but brake test, whereas indirect test is nothing but spin bund test. Just 10 minutes I am giving a complete description, brief description about second unit. Once again please listen. So out of second unit, that is DC motors, main important questions are speed control of DC motor, explain with a neat sketch, then characteristics of DC motors, DC shunt motor and DC series motor. Explain the characteristics of DC shunt and series. Sometimes they asking explain the characteristics of DC motors is nothing but right, shunt, series and compound also. And derive the torque equation, armature torque equation, 0.159 pi ZIA into P by A Newton meter. After they asking losses. Briefly explain the different losses in DC machine means. Generally losses are copper losses, iron losses. So whatever it is a rotating machine or it is a static machine, these two losses are always present. Copper losses, iron losses. Suppose coming to the rotating machine, that is DC machine, mechanical losses are also available. Whereas in transformer, there is no rotation losses, that is mechanical losses. Then explain the spin bund test or explain the indirect test of a DC motor, like that, with a neat sketch, like that they ask it. So most important is speed control, torque equation, losses, 3-point start. These 4 questions are main important. First, generally I am giving a brief description, just 10 minutes, 10 to 15 minutes, and then we are going to the problems. Generally DC motor is nothing but a motor is a device which converts an electrical energy into mechanical energy, right? Whereas in generator, so mechanical to electrical. Coming to the motor, motor is a device which converts an electrical energy into mechanical energy. Exact opposite process of generator. The energy conversion process is exactly opposite to that of involved in the DC generator. But construction of DC motor or DC generator, both are same. Explain the construction of a DC machine or explain the construction of a DC motor or explain the construction of a DC generator, whatever it may be. Construction అనే క్వశ్చన్ ఫస్ట్ యూనిట్ సెకండ్ యూనిట్లో వస్తే మీరు రాయాల్సింది DC generator construction. I mean yoke, pole core, pole shoe, field winding, armature core, armature winding, generator, brushes, bearings. These are the parts of DC machine construction, right? But operation is different for generator and motors. Generally, the principle of operation of DC motor can be involved or can be stated as whenever a current carrying conductor is placed in a magnetic field, whenever a current carrying conductor is placed in a magnetic field, it experiences a mechanical forces. It experiences a mechanical forces. That is the principle of operation of DC motor. How it experiences a mechanical force, that may clearly tells about the last class. Whenever a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. Because of that mechanical force or twisting moment of the force or turning moment of the force, so on the armature, twisting moment or turning moment of the force on the armature, that may develop torque. The definition of torque is nothing but twisting moment or turning moment of force about an axis is called torque. Because of the torque, the motor is running. The motor is running with some RPM, some speed. The torque is the product of force and radius as usual, at which the force acts. So overall armature experiences a torque and starts rotating. Therefore, the motor action, whenever because of torque, the motor is running with some speed. That means it gives a motor will take the action. That means it will running with some speed. Right? How to develop force? Some weak force, some strong force. So right hand side is, so strong force is there, strong magnetic field developed. Left hand side is some weaker flux, whatever it may be. Left hand side gathering strong flux, right hand side gathering weak flux. Therefore, the momentum, the direction will flowing from strong flux to weaker flux. So on that way, the motor will be running, right? So the total concept will be explained in the last class. Just what is the principle of operation of DC motor in the sense, whenever a current carrying conductor is placed in a magnetic field and some force acting on the conductor, because of that force, a torque will be developed. So in the armature, so due to the torque, the motor will be running with some speed, right? Torque is nothing but force into radius. Next, what is the back EMF and what is the significance of back EMF generally? Back EMF is nothing but in motor also generator action takes place. In motor also generator action. What is the generator action? Whenever a conductor cuts the magnetic flux, an EMF is induced in the conductor. So this induced EMF in the armature conductors, according to Faraday's laws of electromagnetic induction. So this induced EMF in the armature is always opposite to that of supply voltage. So in motor itself, generator action takes place. What is the generator action? Whenever a conductor cuts the magnetic flux, an EMF is induced in the conductor. That EMF is always opposite to the top of supply voltage. So this gives the Lenz's law. So this, according to Lenz's law, The EMF induced in the motor is always opposite to that of supply voltage, right? So that EMF is called back EMF. Because of back EMF, the motor is self-regulating to itself. That is the significance of back EMF. So what is the significance of back EMF is in the sense, the motor will acting as a self-regulating, right? So that is the back EMF. That means self-regulating means the back EMF regulates the flow of armature current, and it is automatically alerts the armature current to meet the load requirement. Depending upon the load requirement, it will change its values. So that is the significance of back EMF. Right. Next, we have to derive the torque equation. Torque is nothing but turning and twisting moment of force about an axis, and we have to derive the torque equation, that is TA is equal to armature torque is equal to 0.159 pi Z Ia into P by A Newton meter. So there are three torques are there: armature torque, shaft torque, last torque. Armature torque is the sum of shaft torque plus last torque, right? Then we discuss about the types of DC motors. After that, we discuss about the characteristics. DC motor characteristics mainly involved torque armature characteristics, T versus Ia characteristics, speed armature characteristics, speed N versus Ia characteristics, then speed versus torque N versus T. Former two, that is 1 and 2, armature torque, torque versus armature current, speed versus armature current, both involved in as armature current. That's why that two characteristics are called as electrical characteristics. But coming the last one, that is speed versus torque, it is involved in mechanical terms. That's why it is a mechanical characteristics. And for shunt motor, flux is constant. So to describe the DC motor characteristics, two equations are necessary. T proportional to pi Ia, N proportional to Eb by pi. These two equations are necessary. Torque proportional to pi Ia, N proportional to Eb by pi. So according to these two equations, based on these two equations, we have to clearly explain shunt motor characteristics, series motor characteristics, compound motor characteristics. Right? After then we go for the speed control. Speed control of a DC machine. So generally nowadays industries are growing day to day life more and more. That means some of the industries may running with some speed, some of the industries may running with another speed. That means to meet the load requirement, to meet the user requirement, the speed is not a constant. Speed must be variable. Some of the industries may require below rated speed. Some of the industries may require above rated speed. That's why speed control is necessary nowadays. But the DC motor speed control is very easy and widely used compared to the AC motor speed control. Why? Because in DC motor there is no frequency, whereas in AC motors frequency is there. To control the frequency is the most complicated one. So here there is no frequency. That's why DC motor speed control is very easy and widely used also. According to the back EMF equation, Eb is equal to pi Zn by 60 into P by A. From that, N is proportional to Eb by pi. So from that equation, so the speed control of DC motor is broadly classified into two types: armature control method, speed control method. Armature control method is used for below rated speed only. Flux control method is used for above rated speed only, right? And how to control the above rated speed, how to control the below rated speed, that diagrammatically and graphically advantage, disadvantage all are discussed in theoretical class. So basically armature control method, flux control method. Armature control method is used for below rated speed and flux control method used for above rated speeds. How can you control the means? In armature control method, by increasing the rheostat resistance, armature current decreases. Armature current decreases means back EMF decreases, thus that speed decreases. Whereas in flux control method, you have to reduce the flux such that automatically speed will be increased more than rated speed. On this manner, you have to control the speed of a DC motor easily. So like that. So advantages we have to discuss it in that class. Next, what are the different types of losses? Generally, copper losses and iron losses are more frequently occurred. But extra loss is mechanical losses. Copper losses are occurred mainly in the winding. That's why the losses are mainly copper losses are mainly taking place due to the current flow into the winding. That may winding may be field winding or armature winding, right? So copper losses are directly proportional to the square of the current. Remember, copper loss is nothing but Ia square Ra. That is the armature copper loss. Shunt field copper loss IS square RSH. Series field copper loss ISC square RSC. Right? How can you reduce these losses? Means suppose we are using a good conductor. That means by reducing the resistance of the conductor, we can reduce the armature copper losses. Next, iron losses or core losses are mainly occurred in the magnetic or core. So there are two losses: hysteresis losses, eddy current losses. So hysteresis losses is nothing but mainly these losses are basically due to the reversal of magnetization of the magnetic curve, and these losses are directly proportional to the frequency. How can you reduce this stress loss? Is nothing but by using silicon steel material. Next, eddy current loss means these are eddy current loss is due to the eddy currents. How can you produce eddy currents? Whenever a armature rotates, it cuts the magnetic flux. An EMF gets induced in the core. That EMF will set some leakage currents. That leakage currents, because of that leakage current, some power loss is available. That's why that power loss is called eddy current losses. Eddy current loss mainly proportional to the square of the frequency. Now, how can you reduce the eddy current losses? Means by using laminations, thick laminations. Totally, hysteresis losses plus eddy current losses is nothing but iron losses. How can you reduce the iron losses? Means by using silicon steel laminations. Then mechanical losses. Mechanical losses is nothing but friction and windage losses. Friction and windage losses. These losses are occurred in the shaft itself. This loss is nothing but friction and windage losses. These are also constant losses, right? Efficiency is nothing but output power to input power. Percentage efficiency is nothing but output power by input power. For generator, we know the output. For motor, we know the input. Suppose generator efficiency is equal to P output power by output power plus losses. Whereas motor, we know the input. That's why input minus losses by input. And we are getting the condition for maximum efficiency. Most important, that is variable loss is equal to constant losses. Otherwise, core losses, iron losses is equal to copper losses. That is the condition. Ia square Ra is equal to Pi. Next, test to determine the efficiency for particular load and to determine the characteristics of a DC machine. We are performing tests. So direct test and indirect test. Direct test is nothing but we don't calculate the losses. We just calculate the output power, input power, and determining the efficiency. Whereas in indirect test, you have to determine the first constant losses, that is iron losses. After then you have to calculate the copper losses for different loads, for half load, for full load, for 3/4 load, like that. After then you have to calculate the total losses, then input then output. So totally output by input is nothing but efficiency. So Swinburne test is used for large motors, but coming to the brake test is not used for large motors. And brake test efficiency is the approximate efficiency, whereas in Swinburne test efficiency is more accurate efficiency. And last one is starter. So starter is nothing but extra resistance added in series with the armature circuit. So what is the necessity of starter means? Generally without starter we can start the motor easily, but sometimes abnormal conditions are occurred. At that time more line current will flowing through the armature of a DC motor, such that they may damage the armature winding of DC motors. So to restrict that such high starting current or high excessive current, so we are using a starter. Starter is used to start the DC motor safely at the starting. Generally after reaching the its rated speed, the starter is cutting, so the motor is running with normal speed, right? To reduce the starting current only, we are utilizing starter. Generally starters are three types: 2-point starter, 3-point starter, 4-point starter. 2-point starter is used for DC series motors. 3-point starter shunt motor, and 4-point starter are also used for shunt and compound motors. But in our syllabus, only 3-point starter is there, right? And we discussed it clearly construction operation on that class only. Like these are the brief description about total second unit, that is DC motors. Just 10 minutes అన్నాను, but 20 minutes పట్టింది ఒక్కసారి రివిజన్ చేయడానికి, right? Now we are going to the problems, so don't move the slides, please. So listen, first problem. A DC motor takes an armature current of 110 amperes at 480 volts. The armature circuit resistance is 0.2 ohm. The machine has 6 poles and the armature is lap connected with 864 conductors. The flux per pole is 0.05 Weber. Calculate the speed. And second one, gross torque developed by the armature, right? Calculate the speed and the gross torque developed by the armature, right? So first you have to observe the problem, analyze the problem once again. A DC motor takes an armature current of 110 amperes, that is IA. Armature current IA is equal to 110 amperes at 480 volts, that is the terminal voltage. V is equal to 480 volts. Then armature circuit resistance, that is RA, 0.2 ohms. Machine has 6 poles, P, number of poles P is equal to 6. Armature is lap connected. Lap connected means number of parallel path is equal to number of poles, that is A is equal to P, that is equal to 6. Conductors, 864 conductors, Z. Flux per pole 0.05 Weber. Now calculate the speed. So first one easy, already you have to solve this type of problem in the first unit itself. EB is equal to pi Zn by 60 into P by A. Whereas in generator we write EG, generated EMF, but coming to the motor we are write EB, both are same. In motor itself generator action takes place right now, so that is nothing but in motor we are called as back EMF. EB is equal to pi Z n by 60 into P by A, whereas in generator generated EMF EG is equal to pi Z n by 60 into P by A. So from that, so N is equal to, so P by A, this is lap winding. So P by A both are cancelled to each other. Why? Because 6 6. That means N is equal to 60 into EB by pi Z, right? But we don't know EB value. They don't give an EB value. Back EMF value what you. So we have to find out back EMF first. What is the back EMF equation for motor? EB is equal to V minus IARA. ఆల్రెడీ మన టైప్స్ ఆఫ్ మోటార్స్లో చూసాం. అదే ఒకటే గుర్తు, జనరేటర్ అయితే ప్లస్ వస్తుంది, ఈజీ ఈజ్ ఈక్వల్ టు వి ప్లస్ ఐఏఆర్ఏ, దట్ ఈస్ ద జనరేటెడ్ ఈఎంఎఫ్ ఈక్వేషన్. బట్ మోటార్ మీన్స్ నెగిటివ్ సైన్, ఈబీ ఈజ్ ఈక్వల్ టు వి మైనస్ ఐఏఆర్ఏ. సో దేర్ ఫోర్ ఈబీ ఈజ్ ఈక్వల్ టు వి మైనస్ ఐఏఆర్ఏ. వి మీన్స్ 480 volts minus IA 110 amperes into RA 0.2 ohms. So 480 minus 110 into 0.2. So that is nothing but, so 480 minus 22. So that is equal to 458 volts. So back EMF is equal to 458 volts. We know the formula, we know the back EMF. Now substitute. So N is equal to EB 458. EB is equal to pi 0.05 into Z 864 into N into P means 6 by 60 into A means 6. Therefore by calculating the by rearranging and calculating the all these things, speed is equal to 636 rpm, right? So first one is calculated. Calculate the speed. We are calculating 636 revolutions per minute, right? Now second one, calculate the gross torque developed by the armature. That means, so gross torque or armature torque both are same, right? What is the formula? TA is equal to 0.159 pi Z IA into P by A. Once again I repeat, torque, armature torque equation equal to 0.159 pi Z IA into P by A. So the equation already derived in the last theoretical class, right? So we know 0.159 is the constant, pi they given 0.05, Z they given 864, then IA they given 110, P 6 poles 6, A this is lap winding, this is also 6 by 6. So by calculating the all these things we are getting 756.3 Newton meter, right? 756.3 Newton meter. Torque is equal to 756.3 Newton. Like that you have to determine. So by using the details we can determine the speed first and then determine the armature torque. Before going to the speed, first of all we don't know EB value. For that determine the EB is equal to V minus IARA. So that is equal to some value. After then by using EB value we can determine the speed. After then torque, we know the formula and they given all the details. So 0.159 pi ZIA into P by A Newton meter. So we are getting the required torque 756.3 Newton meter. ఇవే ప్రాబ్లమ్స్ వస్తాయని కాదు, ఇలాంటి ప్రాబ్లమ్స్ మ్యాక్సిమం. Go for the second problem. Determine the developed torque and shaft torque of 220 volts 4-pole series motor with 800 conductors, wave connected, supplying a load of 8.2 kilowatt by taking 45 amperes from the mains The flux per pole is 25 milliweber and its armature circuit resistance is 0.6 ohm. Right? Please analyze the problem. Determine the developed torque and shaft torque. Developed torque is nothing but developed torque. That is nothing but armature developed torque or gross torque. So whatever it may be, the torque developed by the armature. So that is the armature torque. We know the formula already. Last problem we solved the problem also. TA is equal to 0.159 pi ZIA into P by A, right? Pi ZIA into P by A. So this is not A, this is IA. Pi ZIA armature current into P by A. And shaft torque, we know the formula. Shaft torque is equal to 9.55 into output by N, right? So by using the two formulas, we can easily find out the armature torque and shaft torque, right? So developed torque or gross torque or armature torque, both are same. Developed torque or gross torque same as armature torque. Therefore, armature torque is equal to, first of all, write the given data. Terminal voltage V is equal to 220 volts. A 4-pole A is equal to 4, and this is wave connected. That's why P is equal to 4. Capital A is equal to 2 only. Whereas in lap connected, P is equal to A. Both are 6, but it is wave connected. For wave connected, parallel path are always 2. Capital A is equal to always 2 for wave connected. Then conductors Z is equal to 800 and power is equal to 8 load power PL is equal to 8.2 kilowatt and IL by taking 45 amperes. Motor is taking supply, that is nothing but IL, not IA. So before problem they given armature current directly 110, but here
Good morning, sir.
they don't given armature current, they are given load current. Babu, Hazrat, enti?
Sir, sorry, sir. My brother will sing. Okay, sir. Sorry.
Okay. So in this problem, they don't give an armature current, they given supply current. Supply current is nothing but load current, IL, from the mains. And flux per pole is 25 milliweber, 25 into 10 power minus 3 Weber. And armature resistance, RA is equal to 0.6. So now they given all the things for armature torque. Just find out the armature torque. TA is equal to 0.159 pi ZIA into P by A. 0.159 pi. They given pi 25 milliweber, that is 25 into 10 power minus 3 into Z 800 into IA. Okay, look at the problems once again. So this is IL, but this is a series motor, right? For series motor, IA is equal to IL is equal to ISC, right? So that's why IA is equal to IL is equal to ISC. So that is equal to 45 amperes. Suppose a 4-pole shunt motor means this is not equal to IA. It is a series motor. That's why IA is equal to IL is equal to ISC. This is equal to 45 amperes. Therefore, 0.159, 25 into 10 power minus 3, 800 into 45 into P4A2. So by calculating all these things, we are getting armature torque is equal to 286.2 Newton meter. So after then, calculating shaft torque, but shaft torque is nothing but 9.55 into EB by N. 9.55 into EB by N. But we don't know N. N means speed. So we don't know speed. For that, first of all, you have to determine the speed and then determine the shaft torque, TSH. So for determine the speed means, so again we are using EB is equal to pi z n by 60 into P by A formula. For that we have to determine EB value. So EB for motor, EB is equal to V minus IARA. The given terminal voltage, that is 220, minus IA or IL or ISE, all are same, that is 45 into 0.6. So we are getting EB is equal to 193 volts. By using 193 volts, so we can determine this speed. EB is equal to pi z n by 60 into P by A. So here divided by 60 is not appearing. EB is equal to pi z n by 60 into P by A. That is 193 is equal to pi 25 into 10 power minus 3 into 800 into n into 4 by 4 by 2. Pi is not there, by 60. By 60. From that n is equal to 4.825. So RPS here I'm not putting by 60, that's why it is RPS, revolution per second. Suppose I am putting by 60, it is RPM. So therefore TSH is equal to, so output by 2 pi n, otherwise 1 by 2 pi into EB by n, right? So here 1 by 2 pi, that is nothing but value is 9.25 into output, they given 8.2 kilowatt. 8.2 into 10 cube, that is 8200 divided by n 4.825, and we are getting, so TSH is equal to 270.5 Newton meter. So in this way we are determining the armature torque and shaft torque. Look at the problem 3. So this is for, so first two problems based on torque equation. Now third problem is based on speed control methods. A 220 volts DC shunt motor runs at 500 rpm and the armature current is 50 amperes, right? Calculate the speed if the torque is doubled, given that RA is equal to 0.2 ohms. A 220 volt DC shunt motor terminal voltage V is equal to 220 volts and runs at 500 rpm, and N1 motor is run at N1 500 rpm. Armature current IA1 is 50 amperes. Suppose calculate the speed if the torque is doubled. Torque double అయితే speed ni calculate చేయండి అంటున్నాడు. So we know that torque equation, armature torque equation 0.159 pi z IA into P by A, right? So total Z 0.159, PA all are constant, therefore TA proportional to pi IA, right? So from that equation we have to determine the speed. Torque proportional to pi IA, but for shunt motor pi is constant, therefore torque proportional to IA. So TA1 proportional to IA1, TA2 proportional to IA2, therefore TA2 by TA1 is equal to IA2 by IA1, right? So first టార్క్ ఈజ్ డబుల్డ్ అన్నాడు, అంటే సెకండ్ టార్క్ డబుల్ అయింది, అంటే 2 TA1 by TA1, that is nothing but 2 is equal to IA2 by IA1, they given 50, therefore IA2 is equal to 100 amperes, right? So torque doubled, from that line we have to determine IA2. They given IA1 50 amperes and we have determine IA2, that is 100 amperes. Now determine the speed. We know that n proportional to EB by pi, from the back EMF equation n proportional to EB by pi, then this is shunt motor, that's why flux is constant, therefore n proportional to EB, that is N2 by N1 is equal to EB2 by EB1, right? We know the N1 value, how much? This is 500 rpm, and we have to determine N2 value. For that we have to determine EB1, we have to determine EB2 values, right? So we know the back EMF formula EB is equal to V minus IARA. EB is equal to V minus IARA. So by using that formula, EB1 is equal to V minus IA1 RA. So next, EB2 is equal to V minus IA2 RA. Therefore, EB1 is equal to V minus IA1 into RA, that is 220 minus IA1 50. Armature current is 50 into 0.2, that is 210. EB2 is equal to 220 minus IA2 is torque doubled, that means current also doubled. So 100 into 0.2, that is 200 volts. We know the EB1, EB2 values, we know the N1 value. Substitute on that relation. N2 by N1, that is N2 by 500 equal to EB2 200 by EB1 210. So from that we have to determine speed after torque is doubled is 476 RPM. Look at the ones we have to observe. Normal torque, the speed is 500 RPM. If torque is doubled, torque increases. What about speed? Decreases. That's why shunt motor speed torque characteristic is a rectangular hyperbola, decreases as torque increases, speed decreases, right? N proportional to 1 by T. So characteristics already మనం చూస్తున్నాం. సో ఈ ప్రాబ్లం బట్టి మీరు థియరీని అనలైజ్ చేసుకోవచ్చు. టార్క్ పెరిగే కొద్దీ స్పీడ్ తగ్గుతుంది. సో వీ హావ్ డన్ ఇన్ ఏ గుడ్ మేనర్. సో మీరు ఈజీగా అర్థం చేసుకోవచ్చు మనం చేసిన ప్రాబ్లం కరెక్ట్ అయి ఉంటుంది అని, రైట్? నెక్స్ట్ ప్రాబ్లం. A 4-pole 220 volts shunt motor has 540 lap wound conductor. It takes 32 amperes from the supply mains. And develops output power of 5.595 kilowatt. The field winding takes 1 ampere. Armature resistance is 0.09 ohm. Flux per pole is 30 milliweber. Calculate the speed. First one, speed. Second one, torque developed by the note. Torque developed is nothing but armature torque, or it may be a shaft torque, whatever it may be. They don't mention. We can derive any one of. Suppose they mention clearly gross torque, armature torque. We have to determine armature torque only. Determine the shaft torque means shaft torque only. Suppose they don't give a mention maximum armature torque. Sometimes we have to derive the shaft torque. Here why you have to torque develop means we have to assume shaft torque means. So first question లో స్పీడ్ కనుక్కున్నాం కాబట్టి షాఫ్ట్ టార్క్ అయితే ఈజీగా ఉంటుంది. వై బికాజ్ 9.95 బై అవుట్పుట్ బై స్పీడ్ ఆల్రెడీ డెరైవ్డ్ ఇన్ ద సెకండ్ ప్రాబ్లం, రైట్? అదే స్పీడ్ కాకుండా వేరేది ఏదైనా ఉంటే మనం అదైనా ఆర్మేచర్ టార్క్ అని కనుక్కోవచ్చు. ఇక్కడ ఆల్రెడీ ఫస్ట్ ఆప్షన్లో స్పీడ్ కనుక్కున్నాం కాబట్టి సెకండ్ ఆప్షన్లో ఆర్మేచర్ టార్క్ బదులు మనం షాఫ్ట్ టార్క్ కనుక్కుంటాం, అంతే తేడా. సో దే గివెన్ IA. So takes 32 as a shunt motor. Look at the problem once again. So shunt motor takes 32 ampere, that is IL, and output power 5.95 kilowatt. Field winding takes 1 ampere, and ISH means 1 ampere. They given IL, they given ISH. Therefore IA is equal to IL minus ISH. This is a motor. IA is equal to IL minus ISH. For generator, IA is equal to IL plus ISH. So from that equation, IA is equal to 32 minus 1, that is 31 amperes. And determine the EB value, V minus IARA, V 220 minus IA 31 amperes. Already you determined just now. And RA 0.09. Then we are getting EB is equal to 217.2 volts. By using back EMF formula, EB is equal to pi ZN by 60 into P by A. So we are getting EB 217.2, that is equal to 30 milliwebers, that is 30 in 10 power minus 3. Z 540 into N by 60 into 4 by 4, that is by rearranging all the values, we are getting speed is equal to 804.4 rpm. So we have to determine the speed, then determine the torque is nothing but generally armature torque. So most of the times we have to calculate armature torque, 0.159 Z IA into P by A. All the values are there. We have to determine armature torque also. But the first option we have to determine speed means, that's why go for shaft torque. Shaft torque is equal to 9.95 into output by speed. 9.55 into output they given 5.595 into so divided by speed 804.4. Now we are getting shaft torque is equal to 66.5 Newton meter. So in this manner, we have to determine torque values and speed values also, right? So losses problems, torque problems are completed and speed control problems also completed. Now losses and efficiency problems and spin bund test problems, that problems are discussed in next class, that is Saturday. From Saturday we close the second unit, right? Thank you. Any doubt, please ask me. మా ఏమైనా డౌట్స్ ఉంటే అడగండి అమ్మా.